Good morning, students. Today we will start our new chapter, that is hydrogen. The first element of the periodic table. The first member of the periodic table. Sun is called the fireball or the burning ball, and it is only and only due to presence of hydrogen. Hydrogen combines with hydrogen, as a result of which high amount of energy is released. So due to the energy released, the sun is called the burning ball or the fireball. The energy which is produced by the sun is only and only due to chemical reaction taking place between hydrogen and hydrogen. So let us begin this chapter. Point number 1, it is the most abundant element in universe and third most on the surface of earth. If we talk about the element with maximum abundance in universe, then it is hydrogen. But if we talk about earth, then it is the element with third most abundance on surface of earth. Then number 2, hydrogen has the simplest atomic structure among all the atoms or among all the elements. It's the first member, it's the simplest member. So its atomic structure is also simplest, and it is due to presence of one proton inside the nucleus and presence of one electron outside the nucleus. Hydrogen is having one proton inside the nucleus, and outside the nucleus in the extranuclear region we are having one electron. That's why this statement is written, hydrogen has the simplest atomic structure among all other elements. Now, in atomic state, hydrogen is not stable. So the hydrogen combines with another hydrogen and it forms H2. So on earth, it exists in the form of H2 molecule. And this H2 molecule is called dihydrogen, or it is called hydrogen gas. So what is hydrogen gas? Collection of H2 molecules or collection of dihydrogen is your hydrogen gas. After that, point number 3 is about isotopes. Now what do we mean by isotopes? It's a class 9 topic. Definition is very simple. Atoms of the same element. Atoms of the same element having same atomic number but different mass number are called isotopes. It means if we are saying here that atomic number is same, it means that number of protons or number of electrons will be same. The mass number is different, and it is due to different number of neutrons present inside the nucleus. So there are few elements from where if atoms are taken, then all the atoms are not similar, all the atoms are not identical. There are some differences, and this differences is due to different mass number. So what are isotopes? Isotopes can be defined as atoms of the same element having same atomic number but different mass number are called isotopes. Because isotopes have same atomic number, so isotopes will share common position in the periodic table. Let us talk about the isotopes of hydrogen. Hydrogen is having three isotopes. First one is called protium, second one is called deuterium, and third one is called tritium. Protium, it is having one proton inside the nucleus. There is no neutron. So protium is the only atom of the periodic table having no neutron inside the nucleus. Its representation is 1h1. 1 represents atomic number. 1 represents mass number. See, number of protons and number of neutrons is called the mass number. Number of protons or number of electrons is called the atomic number. Here number of proton is 1. So here it is 1. Inside the nucleus we are having only one massive particle, that is proton. So mass number is also 1. So this isotope is having maximum abundance. If we compare the abundance of protium, deuterium and tritium, then its abundance is much higher. That's why whenever we talk about hydrogen, we always talk about protium due to its maximum abundance on Earth. Then we have next isotope, that is called deuterium, which is having one proton and one neutron inside the nucleus. There will be no change in the number of protons or number of electrons. It is the neutron that will be changed. Here there is no neutron. Here there is one neutron. So mass atomic number will remain same 1 because we are having one proton. What about the mass number? Because the nucleus of deuterium contains one proton and one neutron, so its mass number will be 2. So deuterium can also be represented as D. It is also called a heavy hydrogen. Reason is very simple, because its mass is more than protium. When deuterium combines with water, it forms D2O, which is called heavy water. So if the water sample contains more amount of D2O, then it is not good for digestion. This heavy water is used as a moderator in nuclear reactor to control the speed of fast moving neutrons. Fast moving neutrons are passed through the heavy water, as a result of which their speed decreases, and they can bombard it on the nuclear fuel more effectively. So this is D2O. Then we have tritium, having one proton and two neutron. So atomic number remains same, that is 1. But mass number will be 3 because one proton and two neutrons are there. It is also written as T. It is radioactive in nature, and its percentage abundance on Earth is very less. So this is all about the isotopes of hydrogen. Then about the position of hydrogen in periodic table. Remember, the position of hydrogen is always a matter of debate. Where it can be placed. It can be placed with group 1, that is sodium, potassium, rubidium, or it can be placed with group 17 or 70, that is halogen family, fluorine, chlorine, bromine and iodine. That's why it is placed separately in the periodic table, because it resembles with alkali metals. They have properties which is similar to alkali metals, and they have few properties which is similar to halogens. So just to stop the debate whether it is to be placed with alkali metals, that is group 1 elements or group 17 elements, it is placed separately. So let us talk about the similar properties. So first one, resemblance with alkali metals. What are the points where hydrogen resembles alkali metals? Sodium, potassium, rubidium, cesium, francium. So point number 1 is electronic configuration. In hydrogen, the valence shell contains 1 electron. Lithium, the first alkali metal, contains 1 electrons in valence shell. Sodium also contains 1 electron in valence shell. Similarly, potassium, rubidium, cesium and francium also contains 1 electron in the valence shell. Means the number of valence electron is same for hydrogen and alkali metal, that is 1. Then comes point number 2, oxidation stage. In most of the compound, hydrogen exhibits +1 oxidation state, and +1 oxidation state is the only oxidation state for alkali metals. Whenever alkali metals like lithium, sodium, potassium, rubidium, cesium undergoes chemical combination with other elements, they always exhibit oxidation state of +1, like when H combines with Cl, the oxidation state of H is +1 because electronegativity of Cl is more than hydrogen. Now in NaCl, OH of Na is +1. So hydrogen is exhibiting +1 with Cl, Na also exhibits +1 with Cl. So they resemble in their oxidation state in most of the compounds. Then comes combination with electronegative elements. First we will talk about halides, then we will talk about oxides, then we will talk about sulfides. Hydrogen reacts with halogen, oxygen and sulfur in the similar manner as alkali metal reacts with halogen, oxygen and sulfur. The chemical formula will remain same, like Na combined with Cl gives you NaCl. 1 atom of Na combines with 1 atom of Cl gives you halide NaCl. Now what about halide of hydrogen? It also gives HCl. 1 atom of H, 1 atom of Cl. Oxide, when sodium combines with oxygen we get Na2. 2 atoms of nitrogen, 2 atoms of sodium combines with 1 atom of oxygen. Here also we get H2. 2 atoms of hydrogen combines with 1 atom of oxygen. If we talk about sulfur combination, then Na2S we will get here. 2 atoms of sodium combines with 1 atom of sulfur. Similarly, 2 atoms of hydrogen combines with 1 atom of sulfur. So if we talk about the reactivity towards halogen, oxygen, sulfur, hydrogen resembles alkali metals. Now, what are the points where it shows different properties with alkali metals, where similarity is not there? So point number 1 is your ionization enthalpy. Now what is the meaning of ionization enthalpy? The energy required to remove the valence electron from the isolated gaseous atom is called ionization potential or ionization energy. Energy is required to remove the electron always, because there is a force of attraction between nucleus and the electron. So against this force we have to supply energy. If we talk about the ionization potential of alkali metals and hydrogen, then ionization potential of hydrogen is much higher than alkali metals, because all the alkali metals are electropositive in nature. They have electron losing tendency, that's why they are called electropositive elements. So if we talk about IB values, then there is no match between the IB values of hydrogen and alkali metals. Then number 2, difference in halides. H combines with Cl, Na combines with Cl. But when H combines with Cl, we get covalent halide. The bond between HCl is covalent in nature, although it is polar covalent, but sharing of electron is there. But when Na combines with Cl, we get ionic halide. Bond between Na and Cl is ionic in nature. Na is plus and Cl is minus. Bond is formed by transfer of electron. One electron gets transferred from Na to Cl. So here also there is no similarity in the properties. Then comes next one, resemblance with halogens. There are few properties where hydrogen resembles or hydrogen shows similar properties with halogens like fluorine, chlorine, bromine and iodine. Number one is electronic configuration. Hydrogen is having only one electron, but halogen is having 7 electrons. Then how their electronic configuration is same? So we are not talking about the number of electrons in the valence shell. We are talking about the number of electrons required to attain the nearest noble gas electronic configuration. For hydrogen, the nearest noble gas is helium. For fluorine, it is neon. For chlorine, it is argon. Hydrogen requires 1 electron to attain electronic configuration of helium. Fluorine also requires 1 electron to attain electronic configuration of neon, and chlorine requires 1 electron to attain electronic configuration of argon. So in the need of electron, their electronic configuration is same. Now next one is atomicity. What do we mean by atomicity? The number of atoms present in the molecule is called atomicity of the molecule. Hydrogen is diatomic in nature. H2, there are 2 atoms of hydrogen. Fluorine is F2, diatomic. Chlorine is Cl2, diatomic. Bromine is Br2, diatomic. Iodine is I2, diatomic. Hydrogen forms diatomic molecule. Similarly, halogens also form diatomic molecules. Reason is very simple. Hydrogen requires 1 electron to attain noble gas electronic configuration. Fluorine, chlorine, bromine, iodine also requires 1 electron to complete their octet to attain the electronic configuration of noble gas. That's why their atomicity is same. Then we have oxidation state. Hydrogen when combines with metal, or when we are getting metallic hydrides. When H combines with metal, then the compound formula called metallic hydrides. And if metallic hydride is there, then in that case hydrogen always exhibit -1 oxidation state. So here when H combines with Na is electropositive element, Na is a metal, while hydrogen is a non-metal. So OS will be -1, for Na it will be +1. When Na combines with Cl, Cl gets -1. So Cl is getting -1 and H is also getting -1 when they combines with sodium metal. So in oxidation state, somehow their resemblance is there. Then what about dissimilarities, difference from halogens? First, less tendency of hydride formation. Hydrogen in most of the compounds exhibit +1 state, not -1 state. It exhibits -1 state, it forms hydride when it combines with metals. But in most of the compounds, most of the molecules, it exhibits +1 state. But if we talk about halogens, then halogens have tendency to form, to give -1 oxidation state in most of the compounds. So here it is different. Then about absence of unshared electrons. H is having only 1 electron. It shares 1 electron with 1 electron of hydrogen and its nucleus is complete. There is no electron left. But when we talk about Cl, chlorine is having 7 electrons. It requires 1 electron for the completion of the octet. So Cl, by sharing its 1 electron with the 1 electron of chlorine, will complete its octet. What about the 6 electrons? 6 electrons will form 3 lone pair of electrons over each chlorine atom. So here here lone pair of electrons or non-bonded electron pairs or unshared electron pairs are present, but here there is no unshared electron pairs. So it is a brief introduction of hydrogen. That's all for today. Thank you and have a good day.